Welcome back to question 4, November 2021, grade 12 maths paper 2. Let's have a look at this question right here. Very interesting analytical geometry question. It says here in the diagram, the circle has the circle centered at n, which is -1, -3. So here's our center here. Okay, passes through A, which is -1, negative. Okay, there's a point there is passing through. Therefore, which makes this a radius rather. Okay, and then they say that and C, where is C now? Okay, there's a C here. Okay, there's C there. Oh, great stuff. All right, then they said B, which is at -4, is to 2, and C and D and E joined. They are joined to form a parallelogram. Okay, we see them. So these ones here, they're forming a parallelogram. And the C and the E, and there's our B there. They form a parallelogram within the circle. Okay, such that BE is parallel to the x-axis. So such as BE is parallel to the x-axis. Okay, there you go. It's also parallel to the x-axis. Parallel. Okay, CD is a tangent to the circle at point C. Okay, yes, point C here, and CD is given by this here. This is the distance. Okay, this is the distance. Okay, so that's our distance. I think it's going to help us going forward. Maybe we have to use a distance formula somewhere, somehow. Okay, we're just marking that. Okay, guys, if you fully understand the question now, let's all proceed. If you don't, please pause this video, read the question again, make sure that you fully understand, therefore you don't get lost as we move along. All right. Okay, let's move on. 4.1. 4.1 says write down the length of the radius of the circle. All right. Just asking us straight away to write down the length of the radius. I think there's a reason why they just said straight away. Okay. They don't even say calculate. They said just write down. So this line here, it is our radius up until here. Okay, so with that we know that we're moving along the y-axis. So the point here 3, and we also have got the point here -1. Okay, so because we're moving along the y, we need to find out what is this y here. What is this y value that we're moving along, because this gives us the length of the radius. So therefore we say, if we know that when it comes to length or the distance, we don't consider the negative on our coordinates, therefore this will give us a radius which is an, which is also equal to our radius. I know, guys, you're already saying radius doesn't matter as long as you understand the concept, right? So therefore we have got 3 and also -1, but we are gonna consider it as 1 because we don't consider the negativeness of the coordinates when we're dealing with the distance. Okay, you can't be moving at a -1 meter backwards. No. With the distance, we don't deal with the direction. This is not physics. In this case here, we're just looking for the distance, that total distance travels. Whether you are traveling in a positive or a negative direction, the total distance is going to be 4 units. Okay, therefore it's going to be 4 units, and that's how you would deal with that one as well. All right. Okay, moving right along, let's move to 4.2. 4.2 says calculate the following to 4.1. 4.2.1 says calculate the coordinates of C. Coordinates of C, they are here. Okay, so let's come here and say coordinates of C. Okay, I've already promised you guys that whenever I move to a next question, I'll use a different color. Here I am. Okay, here's C here. If you have a look at this C, where C is sitting. Okay, let me remove these ones from the previous question. Okay, let me remove them. Okay, so that is easy for you guys to see and follow. Great stuff. So now, if you have a look at this C here, they want us to calculate the coordinates of C. So there's a line here, which is what? Radius. And then there's a line here as well joining the other side, which is radius. So this gives you the diameter. Okay, so now if you have a look at it, it means this radius and these ones, they are therefore equal. So therefore, which brings us to a conclusion to say, if you have got a line that has got equal sides on both sides. Okay, let me write it here clearly for you guys to see. Here's C here, and in here you've got N here, and then here you've got your A. Okay, your A is -1 is to -1, and then your C is -1 is to 3, no, N rather. Therefore your C, you don't know what is C. Okay, but I can already know there's another way. But yeah, anyway, let's do it properly with the formula, né? So this is your X at C, this is your Y at C. Okay, do you guys agree with me that N here, it is also the midpoint of this line? Okay, this is the midpoint of this line. Why am I saying that? Because there's equal size of radius on each side. Okay, so this is N here, it is also the midpoint, because radius and radius, they are therefore equal, therefore is the midpoint. So if N is the midpoint, it means we can use the midpoint formula to find the coordinates of C thereof. Okay, let me come here and say, okay, coordinates at the midpoint, we are going to say here the coordinates at the midpoint, which is X at N, is going to be equals to X at, let me see, X at A plus X at C all over 2. Okay, similar thing would apply with Y. Y at N is going to be equals to Y at A plus Y at C all over 2. Midpoint formula in reverse. I think we did a question like this one in the previous paper of November 2022. All right, okay, let's come here. Our midpoint here is here at N, so it's going to be -1 is equals to -1 at A plus X at C. We don't know, that's what we're looking for, divided by 2. Therefore we're going to do our cross multiplication here. X at C -1 is going to be equals to -2. Then you take the 2 to the other side, is going to be X at C -1, -2 rather, plus 1 is going to give us -1. Okay, makes sense. All right, let's come here, move right along to the Y1. Okay, we have got 3 here at N, then at A is -1 plus Y at C. This is what we're looking for, all divided by 2. Cross multiplying, put a line here, cross multiply, you are going to get Y at C -1 is going to be equals to 6. Therefore you take Y to the other side, 6 plus 1 is going to be equals to 7C. All right, therefore this gives us the coordinates of C as being -1 is to 7. Great stuff, guys. I hope you're really following this one and you really understood. So let's come right here along. They said calculate the coordinates of D. All right, now the coordinates of D, if you have a look at this one, guys, okay, if you have a look at this one here, you would say, coming here, you would say, okay, coordinates of D. Okay, you have got here the coordinates of C. We just calculated them is -1 is to 7. They have given us the distance here, which is 6 units. We don't know the coordinates of D. X at D, we don't know what it is, and therefore Y at D. Okay, so now looking at this, okay, if you have a look at it, either, guys, you can use the distance formula, no problem. You can apply the distance formula if you want. I'm just gonna show one way of doing it. Okay, let's come here, 4.2.2. I'm only gonna show one way of doing it. Okay, right, let's come here and say, if you have a look at this equation here, the C and D, because they are sitting on the same line like that. Okay, there you go. You say C is -1 is to 7, or X, ne? So our D, okay, and is 6 units here. If you have a look at, when you move that side, what are you changing? You're only changing the X value, because you're not moving up and down. Do you guys agree with me? You would agree with me if I say that the Y value stays the same whether you are at C or you are at D, because it does not change. It's only here, which is happens to be 7. So it means the Y here is also 7. Okay, makes sense, guys. So now we are saying there's a change in the X value when you're moving along this line, which is changing by how much? By 6 units. Okay, it has changed by 6 units, moving to that side. All right, so therefore it means the only thing that will change here, the x at D would therefore be equal to the distance on the x minus the x. Therefore it's going to give us 5. Is it? Yes, it is what it is. Then it makes sense, guys, that our x value from the distance formula, because we are only changing the x values when we move along this, therefore it gives us the coordinates value therefore of D to be 5:7. Coordinates of D to be 5:7. I know what you're thinking, guys. You're thinking, okay, but say, well, can I do this differently? Yes, you can. 100% you can do this differently. There are many ways to kill a cat. This one, what you can do, you can use the distance formula to calculate that, but you need to realize first that 7 remains the same on the 2. So with that, you can go and substitute into the distance formula by saying, I think you guys deserve me to show it here. You can come here and say, okay, the coordinates of CD is going to be square root of x, okay, x at C minus x at D, okay, all squared plus y at C minus, minus rather, I'm writing positive here, minus yd all squared. Okay, so you already know this one. It's what, 6 units. I'm not going to do the whole of the question, guys, for the sake of space here on my side. We know the x coordinate is c is minus 1 minus x d, we don't know this one, all squared, plus y at c is given by 7, but now we know the y here, which is given by minus 7 as well, squared. Okay, can you see, guys? Therefore you can substitute, do the algebra, then you solve for x at D. Okay, then you can solve for x at D, and that's how it goes, guys. Sorry about that. And that's how it goes, guys. Then you would therefore be able to find this equation. All right, great stuff. So let's move right along to 4.3. okay, moving right along to 4.2.3 rather, 4.2.3. it says that calculate the area of ACD. Okay, ACD. I want us to calculate the area of A. Where is A? A is here, A, C, and D. Wow. So they want us to calculate this area here. Oh, okay. There's a perpendicular line there. Okay, it should be fairly easy because you already have this line here. And therefore, this gives us a right angle triangle. No. They said B, C, D. Where's B? B, C, and D. Area of B, C, D. Okay, let me see. So it means I have to remove this, all these guys. I'm marking it wrong here. Okay, good stuff. So now let me see area of C, of B, C, and D. Okay, so therefore this is the area that we are looking for here. There it is. So now with the area of a triangle, let me come here, 4.2.3. We already know with the area of a triangle that looks like that, you all need this height here to get the area, and therefore you know that the area will be given by area of any triangle is given by half base times perpendicular height, which is going to be this perpendicular height here, and then our base will therefore be this one. So for in this case, we've got C there, we've got D there, we've got B here, and what is this perpendicular height of ours here up until there? All right, so we already know this perpendicular height here, that it is our radius. Okay, so and our radius was therefore given by how much? We did get our radius somewhere here. Okay, our radius is given by 5, because you just need to find this 5 here. Okay, so but you're asking yourself, say, how did you manage to get to 5? Here we go. So the distance, the perpendicular height, is the height between C and, okay, it is going to be given by the y coordinates, because when you move along here, you are only changing the y coordinates. So the y coordinates at C is 5, and therefore minus that at N, which is 3, which gives us 5 units, and this therefore refers to our radius. Okay guys, there you go. So therefore that is our radius. So now let's go ahead and look for our B, which is our breadth here. Our breadth is going to be given by CD. Okay, is it? Yes, it's going to be given by CD. And why you are asking yourself for, say, but why are you saying it's going to be given by CD? If you have a look at this triangle, this is the breadth because it's upside down. Okay, have a look at it, it's upside down. If you turn it around here, I think I made a mistake here. This is our base. Okay, and we already been given our base as 6 units. Okay, so let's go ahead and come and substitute. Okay, area of a triangle BCD will be given by half, which is our base. In this case, our base is CD times our perpendicular height. In this case, the perpendicular height was given by CN, by the distance of CN. Okay, so you are gonna come here and say half CD 6 units, and therefore CN is going to be 5. And therefore once you punch this into our calculator, is giving me 15 units squared. Okay, it gives me 15 units squared, guys, and that's how you deal with a question like this one. If you still don't understand, please let me know on the comment section below. I will definitely assist you, or reach out, subscribe to this channel so that you can see all the answers that to follow. And you can also see on this playlist we have got, if you watch this video until the end of the video, you will see up here we do have a video of question for November 2020 as well. All right, let's move on to 4.3. With that said, 4.3 is here. Okay, great stuff. Let's come here and deal with this one. 4.3. 4.3 says here, 4.3 says the circle centered at N is reflected about the x, about the y is equals to x. Okay, line, you guys know the line y is equals to x is this one here. Okay, no, not like that. It must be passing here at the origin, is this one here. So this is the line y is equals to x. Okay, and then M is the center of the new cycle, okay, which is formed. The two cycles intersect at A and F, so it means there's a new cycle that is formed here. It means there's a new cycle that is formed here. I think F should be somewhere there. There's a new cycle that is formed here. All right, great stuff. So now they said 4.3.1 says calculate the length of MN. What do we have? We've got N is here. Where is M? M is the new center, which is going to be somewhere here, which is our M there. What is the new center? So now they're asking us to calculate that. Okay, remember they said this is a reflection. So what happens when you reflect these coordinates to here? Okay, so if you reflect the coordinates, guys, I think you did that in grade is it grade 9, where you do reflection. What you do with the reflection, so you have this coordinate of N here, -1:3. So if you were to reflect this, you need to swap the X and Y. Okay, so we're gonna swap the X and Y. Is it? Yes, we swap the X and Y. Okay, we swap the X and Y. Okay, what is the N here? There we go. We swap the X and Y. So this 3 here is going to become our new X, and therefore this one here is going to become our new Y. But however, we are in the 4th quadrant. So in the 4th quadrant, what is negative there? Okay, no. What is negative here? Our Y is negative, yes. There you go. So because we are in this quadrant here, so this is going to be 3:-1. So please guys, you must know the reflection. Okay, what to do when you reflect something along a given line. Okay, especially along this line y is equals to x here. All right, great stuff. Okay, now they're looking as for, they said we must find the distance between mn. So we know mn. What is our distance formula there? Our distance formula is going to be given by x2 minus x1 squared is plus here y2 minus y1 all squared. Okay, so therefore now we can choose this one as our first coordinate and this is our second coordinate. Let's go here, substitute into this original equation here. Okay, x2 is going to be equals to 3 minus into minus 1 all squared plus y is going to minus 1 minus and then all squared there. Therefore, if we punch this into our calculator, we should be able to find, let me see what I'm getting here into my calculator, is giving me 32, square root of 32 units. Okay, and that's how you deal with a question like this one. Let's move on to, yes guys, let's move on to 3.3.2. If guys you don't understand, please make sure that you subscribe on this channel. I am Castin Mapala. I will definitely see you on the next upload where we'll be doing question for November 2020. Stay tuned.